I hope everyone is okay. In this video, we are going to look at extraction of metals, extraction of metals. Okay, now before we even proceed looking at the extraction of metals, you need to know the properties of metals. Remember, on the periodic table, a periodic table is a table of elements, both metals and non-metals. So what you do is that when you look at metals, there is a zigzag line where there is boron and the aluminum down. That zigzag line demarcates metals from non-metals. Okay? And the other thing that you need to know is that properties of metals, the general properties of metals. General properties of metals, number one is that metals are malleable. Metals are malleable. So what is malleability? What is malleable? Anyone with an idea? What's the meaning of malleable? They can be hammered into different what? Shapes. How about ductile? They can be drawn into wires, or thin sheets. So we have, they are malleable, they are ductile or ductile, they are sonorous. Sonority or sonorosity is the ability of metals to produce sound. So now, when a metal is struck, they produce a high-pitched sound that is this property. They are good conductors of electricity. The other thing is that they have high boiling and melting point, except mercury, which is a liquid metal. Okay? And you have a lot of properties. Now, let's just look at these. Now, the next thing that you need to know is the reactivity series of metals. Reactivity series of metals. Reactivity series, it is a list of elements arranged in the increasing order of reactivity, where you have the most reactive metal at the top and the least reactive metal at the bottom. So it's like this. So I'm going to write, I will write them in their decreasing order of reactivity. Decreasing order of reactivity, the same as descending order, where you start with the most reactive on top. So we are going to start with potassium. The symbol for potassium is K. Then we have sodium. The symbol for sodium is Na. Then you have magnesium, which is just Mg. Then you have calcium, Ca. You also have zinc, Zn. Okay, you can have aluminum, then zinc here. Then you have iron, you have hydrogen, you can have copper, and other elements down there. So now, I'm interested in the first 5 elements. Potassium, sodium, magnesium, calcium, aluminum, even zinc and iron. In fact, just look at these. Because remember, we are looking at extraction of metals. Now, what is the criteria for extracting a metal? The criteria is that, number one, the position of the metal on the reactivity series. The first 5 elements, potassium, sodium, magnesium, calcium, and aluminum, These are the most reactive metals on the on the reactivity series. Therefore, they can only be extracted by electrolysis, where you apply electricity. Okay? Zinc and iron here, they can be extracted by reduction. Okay, reduction by Koch, reduction method. But the first 5 elements, electrolysis. This one is the reduction. Yes, by Koch. By Koch, which is carbon, right? Yes. So now, let's look at the extraction. Let's start with reduction first. Let's look at extraction of zinc. Extraction of zinc. Okay. Okay, let me just I'll write it from here. Extraction of zinc. Extraction of zinc. Now, the method by which zinc is extracted is reduction method. Now, you need to know what the ores of zinc. Ores of what? Zinc. An ore is a compound or a mixture of a metal with impurities. So it's a mixture of impurities from which a metal is extracted. That is a what? An ore. In this case, ores of zinc, we're going to look at 2 ores of zinc. We have zinc blend, and we have calamine. Zinc blend and calamine. Now, what is the chemical name for zinc blend? What is the chemical name for zinc blend? Yes? Zinc sulfide. Very good. Zinc sulfide. The symbol is just Zn what? ZNS. Okay, ZNS. How about calamine? What is the chemical name for calamine? Calcium, zinc carbonate. So it is zinc carbonate, not calcium carbonate. Zinc carbonate. The formula is just ZnCO3. ZnCO what? CO3. Okay. Now, in this extraction, we are going to use zinc blend. Let's now go into the actual extraction. Is this side visible? This side. Okay, actual extraction. All right, so now you have stage 1. The first step or the first stage is that the zinc blend is roasted in air. Okay, the zinc blend is roasted in air. So when the zinc blend is roasted in air, it means that it reacts with oxygen. It reacts with the oxygen. Okay. It reacts with oxygen. The zinc blend is roasted in air. It means that the zinc blend, which is ZNS, reacts with what? Oxygen to form zinc. Zinc what? To form zinc what? Zinc oxide and the what? Sulfur dioxide. Now, the sulfur dioxide here is a gas, a toxic gas that is not allowed, that shouldn't be allowed to escape into the atmosphere. The reason is very simple. Why? So the reason is very simple for not allowing or letting sulfur dioxide escape into the atmosphere. What could be the reason? Exactly. And what is the effect of acidic rain? It destroys the buildings, made of calcium carbonate, which is limestone or cement. Okay, very good. So it combines with rain and form acidic rain, and the name of the acid will be sulfuric what? Sulfuric acid. Therefore, it has a one use. The use of sulfur dioxide is used in the manufacture of sulfuric acid. Good. All right. So now zinc sulfide is solid, right? This is a gas. This is solid. This is what? A gas. Now, in the second stage, which is stage 2, we'll use zinc what? Oxide. Zinc oxide produced in the first stage proceeds to the next what? Stage, where it reacts with what? No. Where it is reduced by carbon monoxide. Okay? Carbon what? Carbon monoxide, it is reduced to what? Zinc and the carbon dioxide. Very good. Very good. Now, where does carbon dioxide come from? Carbon monoxide, sorry, come from? When someone is burning material. Yes, it's a reducing agent. Now, where does it come from? Remember, the process is, the method is reduction by coke. So remember, coke reacts with oxygen to form carbon dioxide. Then the carbon dioxide further coke to form carbon monoxide. Exactly. That's it. So that's the carbon monoxide which is here, and it's a reducing agent. Correct. Reducing agent. So the zinc formed here is in the molten state, which is liquid state. We can balance these equations. This equation is not balanced. Let's balance these equations, by the way. Zinc atom, here we have only one. Sulfur, we have one. This side, we have one. You have 2 atoms of oxygen. Here we have 3 atoms of oxygen. What do we do to balance this one up? We put a 2 here so it becomes a 4, and a 2 here so even here it becomes a 4. Because of these 2 zinc atoms have been affected, we all have to put a 2 here. And what do? Sulfur is also affected. What do we do? When we put a 2 here, zinc sulfur balanced, but number of oxygen atoms has been affected. This we have 4, we have 2, 4 here. So this is 6, Okay? So put a 3 here, and everything is balanced. Let's go to the uses of zinc. We are done. Extraction of zinc. We are just summarizing extraction of metals. So zinc is used to galvanize iron. Okay, to prevent what? Corrosion or rusting of what? Iron. Very important. Next, zinc. Yes, zinc is used to make what? Alloys. Such as what? Brass. Brass is an alloy of wood, zinc and copper. Zinc and copper. 3. What is the third usage of zinc? It's used in the making of what? Roofing sheets. Roofing sheets. And then the other one is used in the manufacture of dry cell batteries. Okay, you have many uses, but let's just stick to the 4 we've illustrated. All right. So this marks the end of extraction of metals, particularly extraction of zinc. We don't want to make the video long. We'll cut it and then record extraction of iron. Okay, cut and record extraction of iron. Any questions? Okay, I'll ask you questions. What is the chief ore of zinc? The main ore, zinc blende. What is its chemical name? Zinc sulfide, eh? Okay. Then what's this one? When zinc blend is roasted in air, a toxic gas is formed. What is the name of that toxic gas? Sulfuric acid, no. Sulfur dioxide, yes. Now, this gas is toxic and it shouldn't be allowed to escape into the atmosphere. Why shouldn't this gas be allowed to escape into the atmosphere? Acidic rain. What is the reducing agent in the whole process of extraction of zinc? Carbon monoxide. Okay. Give me at least 4 uses of zinc. Alloying, galvanizing. Brass is the same as alloys. Roofing sheets, dry cell batteries, huh? Okay. Now